Okay, folks, section 15.4, variables and equations. Now, you've been working with variables, okay? We've been putting them together with like terms, right? We've been simplifying expressions. Now we're going to start talking about equations. And an equation is when we've got one expression, like 2x plus 4, is equal to another expression, say 5, okay? This is an expression, and this is an expression. And an equation is like a number sentence. It's saying this is the same as that, period. 2x plus 4 is the same as 5. Two expressions that are equal to each other, okay? Now I'm going to read through this first part. It says an equation is a mathematical sentence formed by placing an equal sign between two expressions. That's what I just said, but I said it better. I don't know if I said it better, but I'm just... Okay? A solution of an equation with a variable is a number that produces a true statement when it is substituted for the variable. For instance, let me just give you an example. 2x is equal to 4. Okay? The solution to this equation is what? What is it, Barrett? It's 2, when x is equal to 2. 2 is a solution because it gives us a true statement. It says 2 times 2 equals 4, and 2 times 2 is 4, and then we get something that says 4 equals 4 when we evaluate it, right? If we put it back in there, we get 2 times 2 is equal to 4. 2 times 2 is 4 is equal to 4. That's a true statement. 4 does equal 4. Good. So 2 is a solution. Let me show you this. What if I plug in 3? If I say 2 times 3 is equal to 4. Well, 2 times 3 is 6 equals 4. Is this true? Does 6 equal 4? No, that's not true. That means that 3 is not a solution because it didn't give us a true statement. It gave us a false statement. Okay. Now, the first thing that we're going to practice on this first example is we're going to practice writing an equation from words. Okay? So for instance, example number 1a, it says the sum of x and 6 is 9. Now, is it important that you know what sum, quotient, difference, and product mean? It is important, okay, for this very reason. Can you tell me, what does the equation look like? Well, there's some things that you need to know. The word is means what in math? Moreau? Equals, okay? The word sum means what in math, Rowan? An addition problem, okay? So why don't you set up this equation for us? Raise your hand if you want to set it up for us. Good. Daniel?
Sum?
It says the sum of x and 6 is 9. What does that look like?
So 9 plus 17 is...
Now wait, it says the sum of, what are the two things that I'm adding? X and 6. The sum of x and 6, and I always do it in order. X and 6 for that, okay? What does is mean, Daniel? Equals what? 9. Done. There we wrote an equation from the sentence. Hannah, will you do the next one for me? It says the difference of 12 and y is 15. What is a difference?
Difference is the answer to a subtraction.
It is. And what are the two things that we're subtracting?
You are subtracting 12 and y.
Okay, so we're going to do it. We'll do it in that order. 12 minus y, and that is what?
That is
15. Okay, is means equals, and then we just write 15 there. Well done. Emma, you want to do the next one for us?
negative 4 times p.
Negative 4 times p. That's right, that is what a product is. How do I write negative 4 times p? What does it look like?
Negative 4.
Negative 4.
Parentheses.
Do I need a parentheses between a number and a letter?
No.
No, I just write them right next to each other. I would if they were both numbers. But a number and a letter, I don't need to distinguish between the two of them because they don't look the same, right? So it's negative 4p. What is?
Equals.
Equals 32. Product is multiplication. Good question, Isabella. Okay. Zachary, will you do the next one for me? What is a quotient?
The answer to a division.
A division problem, okay? Now it says the quotient of n and 2 is 9. Now how do I write a division problem in the 6th grade, Zachary?
You write it as a fraction.
You write it as a fraction, okay? And which one of these goes on top, n or 2?
2.
No. The number mentioned first goes on top. Which one of the numbers that are being divided was mentioned first? N. So we're going to write it as n divided by 2. Now where do I go, Zachary?
Then you put equals 9.
Exactly. Equals 9.
But it says like n and 2 already. So you would be putting n and 2 together. So then you
But wait, it's the
that.
quotient of n and 2. So I need to write them as a division problem,
Oh.
right?
Yeah.
If I were in the 5th grade, I'd say n divided by 2, but I'm not. I'm in the 6th grade, so I'm going to say n over 2. The first one mentioned goes on top. Okay? You guys ready for the next one? Let's see what we get on the next exam. Okay, good job there. Tell whether 9 or 7 is a solution of x minus 5 equals 2. Now think about this. Remember earlier I did 2 times x equals 4? I plugged in 2 and that was true. I plugged in 3 and that was not true. Okay? So to see if something is a solution, what do I have to do, Jenna? Plug in the numbers. Now how many numbers do I need to check? 2. So I'm going to write the equation twice. Okay? X minus 5 equals 2. But instead of x, I put parentheses so I can plug in. And then x minus 5 equals 2. Okay? Jenna, what would you like to plug in here? 9. 9. So this is 9 minus 5 equals 2. Jenna, what is 9 minus 5? 4. Does 4 equal 2? That's not true. So 9 is not a solution. 9 is not a solution. Okay? Good. David, what do I plug in the other one?
You put in, bring down, wait, you're on the same one, right?
I am.
Oh, sorry. You plug in, X. Wait.
Mm-mm. Hang on, David. Stay with us. Okay? Aiden,
Yes, sir.
what do I plug in now?
You plug in 5.
Okay. Allie, what do I need to plug in? I need to plug in 7. I checked 9. It was not a solution. Let's check 7. That gives me 7 minus 5 equals 2. What is 7 minus 5, Allie? 2 equals 2. Is that true? All right, so 7 is a solution. All we have to do is plug it in to see if it gives us something that's true. Okay? And if it does, then it is a solution. Okay, let's look at the next one. Oh my goodness. Solving equations. Finding all solutions of an equation is called solving the equation. Okay? You can use mental math to solve a simple equation by thinking of the equation as a question. Okay? All right, you can do that. Now, as the equations get more complex, there's a process called inverse operations that helps us solve the equation. But looking at these, they're pretty simple. Okay? X plus 3 equals 11. What is the question? What is the question, Jenna?
What plus 3 equals 11?
What plus 3 equals 11? And what plus 3 equals 11, Jenna? 8. Now they want us to check that. All right, so let's plug in 8 for x. 8 plus 3 equals 11. Is that true? Good. Nice. Okay. Vivian, 16 minus 5 equals 9. How do I write that question?
16 minus what?
16 minus what equals 9? 16 minus what equals 9, Vivian? 7. Let's plug that in and just make sure, let's look at it in front of us. 16 minus 7 equals 9. Is that true? 16 minus 7? Yeah, that's good. Equals 9. Well done. Okay. 20 equals 5t. Elizabeth, what's it saying? Or what's it asking?
What 5 times 1 equals
5 times what is 20, right? Well, 5 times what is 20, Elizabeth? 4. Well, let's plug it in. 20 equals 5 parentheses 4. Emma, do you see why I need to put parentheses between the 5 and 4? Because if I didn't, it'd look like 54, right? That's the only reason I need it, all right? 5 times 4, does that equal 20? Good, all right? Just some simple, this is just mental stuff, all right? Y over 6 equals negative 3. What question is it asking us? David?
What divided by 6 equals negative 3?
What, this is a toughie, what divided by 6 is negative 3? I should say is, not equals. Okay? Is negative 3. What number divided into 6 parts is negative 3? David?
Negative 18.
Negative 18. Nicely done. Negative 18. So now I've got negative 18 over 3 equals negative 6. I'm sorry, I did that exactly wrong. Over 6 equals negative 3. Is that true, David? Negative 18 divided by positive 6 equals negative 3?
Yes.
Good. Nice job. Nice job. Shall we look at the next one? You guys doing okay? All right, let's look at the next one. How many do we have? 4? No, just 4. Okay, we're good. From 1998 to 2002, biologist Jane Shenmiller grew several lotus plants from ancient seeds that she found in China. The oldest seed was about 500 years old. Estimate the year when this seed was formed. Estimate the year. Okay, now remember, from 1998 to 2002, she grew several lotus plants from ancient seeds. The oldest was about 500 years old. Estimate the year when this seed was formed. Will you please give me an equation? An equation that might work for us here. What do you think, Zachary?
So 1998
1998
plus 2002. Wait, no. No. Minus 2002.
I don't think that's it either.
9.
No? Hannah, what do you think?
Minus 500.
Minus 500 is equal to x, the thing that we're looking for. So when we solve this, what do you get here, Hannah, when I do that subtraction?
You would get 1,498.
So about 1498 to what? They said estimate. Remember, she did this from 1998 to 2002. If it were exactly 4, you were just estimating. What do you think? 1498, Daniel? 1498 to 5002? I'm sorry, 1502?
Yeah.
Right? 4 year span? If the seed was exactly 500 years old? Okay. The year. Why don't we just do AD? How's that? Everybody good with that? All right, nice job. I think you're ready for your homework.